Hey guys, Mr. Ye here again, and today we're going to be talking about lesson 2.2 in our textbook, which deals with linear equations. So when we start talking about this topic, the first thing I like to do is look at the word linear and highlight the root word present, and that's those first four letters, L-I-N-E, line. This describes the shape of every linear equation. Sometimes they go uphill, like that one on the left-hand side of the screen. Sometimes they're going to start high and go downhill as we move left to right. They might be horizontal, they might be vertical lines going straight up and down, but every linear equation is a straight line. Goes on forever, no curves or anything like that, just one straight continuous line. When we are talking about linear equations, there are three main forms that we discuss. And so these are really useful both to be able to represent linear equations, but also to interpret them when we see them, these different forms. The first one on the screen, ax plus by equals c, we call this standard form. And standard form, as you can see, gets the x's and y's on the same side of the equation. A, b, and c are just some numbers, some coefficient is the official word for them. The number of x's, the number of y's, and then just that constant term on the other side of the equation. So for example, like 7x plus 4y equals 10. That would be in standard form. The second form of a linear equation that's written on the screen is what we are often most familiar with. We call this, sorry, I got ahead of myself. We call this one slope-intercept form. And the reason it has this name is pretty straightforward because, and hopefully this looks familiar to you, m in mathematics represents the slope of a line most often, and b represents the y-intercept. And so why is it called slope-intercept form? Because just looking at it, we immediately know the slope of the line and the y-intercept. That's a really useful one that you've probably seen multiple times before, and we will be talking about that this chapter as well. The third form of a linear equation on the screen right now is the one I started to write a second ago, and that is point-slope form. And just like slope-intercept form, it is named point-slope form for a really, really logical reason. It contains a point that is on the line. So x1, comma y1 are coordinates of a point that actually exists on the line itself. And then once again, we see this m, which represents the slope of the line. So y minus y1 equals m times x minus x1. That is point-slope form, and we're going to be diving a little bit deeper into that in a later video in a future section. But for now, you should know that these are the three main ways to represent lines when we're talking algebraically and putting them in these different forms. Today, we are going to be focusing mostly on standard form, that ax plus by equals c. So before we really hit up that standard form and dive in deep, just some things about linear equations. How do we get just a straight line? Well, we do this in a variety of ways. First one, in linear equations, variables are not multiplied together. We never see x times y or x times y times z. It's always just the x's are on their own, maybe a number beside them, right? 4x or something. The y's on their own, and then a constant. Linear equations do not feature variables in the denominator of a fraction. In other words, we're not going to divide by a variable. So we will never see like 3 divided by x or something like that. We will not see that variable in the denominator. No variables as exponents. So don't have 3 to the xth power or something like that. X is not in that exponent. That is not there. And then they have a degree of 1. And what does that mean? Well, having a degree of 1 means we don't see any x squareds. That has a degree of 2. We don't see any x cubes that would have a degree of 3. So degree kind of means the power that the variables are raised to. And there's a little bit more to that definition of degree, and we'll talk about that later this year. But for now, know that having a degree of 1 means the highest power of x that we see is x to the first, or just x. That's typically how we see it. And the highest power of y that we see is just y to the first, or y. So when we are looking to see if things are linear or not, one of the questions we ask ourselves is, can the function be written as f of x equals mx plus b? And there's that slope-intercept form from above. Can we represent a linear relation like this? And if so, it is a linear function where m and b are real numbers. So what I would like you to do is think about those rules that we just saw that you might have just written down. And I've got 5 functions. As they're written, they look like functions here on the screen. I want you to look at each of them and think to yourself, is this a linear function or not? Does it break any of the rules we just talked about, or is it good to go? Pause the video, take 30 seconds, decide which of these are linear, which of these are not. I will give you a clue. 2 of them are linear functions. 3 of them are not. So pause the video, decide which 2 you think they are, and see if you can identify why they are, whereas the other 3 are not. And in a second, we'll come back and look to see if you got those correct. All right, hopefully you had a chance to pause the video and decide for yourself, and decide that this first f of x function is in fact linear. 10 minus 5x. We don't divide by any variables. We aren't multiplying variables by each other. Degree is 1, x to the first. We don't have any x's or variables as exponents. This meets all the criteria. And if you look, we could write this in slope-intercept form really easily just by switching the order on the right-hand side, negative 5x plus 10. So equation number 1 is a linear function. Equation number 2 is not. And why not? Because of this x squared there. Hopefully you spotted that and remembered, wait a second, degree had to be 1. If we see 2x squared, it won't be a straight line, and that automatically disqualifies it from being a linear function. Similar reason for equation number 3, x squared, that's enough to disqualify it. Y to the 5th, that's enough to disqualify it. The fact that these variables are being multiplied by each other makes this just an utter failure, definitely not a linear function that we're looking at for the third one. The fourth one looks a little more promising. We only see x to the first, things like that, but we are dividing by a variable which we said was a no-go with linear functions. So dividing by the x, not linear. Which means, based on the hint I gave you earlier, this 5th one has to be linear, and it is. The potentially tricky part is you're seeing division, you're seeing fractions, you're saying, wait a second, negative 3 divided by 2x, is that allowed? The answer is yes. This is still just a coefficient being multiplied by x to the first. Yes, it's a fraction, but it's still just a number. So this last one, again, it doesn't have any x squareds or x cubes, it doesn't have x times y. We're not dividing by x anywhere. This is a proper linear function. So hopefully that exercise gave you a little bit of an idea of what a linear function looks like, so that you can identify them as we continue on. So I mentioned earlier that a lot of the focus today has to do with standard form of linear equations. Ax plus by equals c. And there's an own set of guidelines and rules for standard form. First off, it needs to look like that. Ax plus by equals c. And so notice that the x's and y's are on one side of the equation, the constant, just the number, is on the other. Excuse me. So as you're looking at those bullet points, you see that there are more rules. A, B, and C have to be integers, whole numbers, for this to be considered in standard form. So no fractional coefficients for the x's or the y's, and no fractional number for the constant, I guess you would say. In addition to that, A has to be positive. We want a positive number of x's. So if that means just adding it to the other side and kind of flipping things around, and that's what we do. But we always want our x's to be positive. We want a, b, and c to all be integers, whole numbers. And then this final one is the one that gets neglected and overlooked most often. The greatest common factor of a, b, and c is 1, meaning we cannot divide anything out of this equation. If all of them are even, we could divide out a 2, right? And so it would not be in standard form until the greatest common factor of those 3 numbers is 1. You can think of it almost like simplifying the equation. So, couple exercises here. Put the following equations in standard form, identify a, b, and c, and we're starting with 3x equals 6y plus 9. When I look at this and I say, I know I need to get it into standard form right here, ax plus by equals c. Well, that means I need the x's and y's on the same side. That's the first thing I notice. I could either subtract 6y over to the left, or I could subtract 3x over to the right. But one of these things is smarter than the other. I'm going to subtract 6y on both sides. And the reason being, I'm keeping my x's positive. Remember that second bullet point, a has to be positive for it to be considered in standard form. So I'm going to keep my x's on the side where they're positive, and I'm going to have 3x minus 6y, we were subtracting it, minus 6y equals positive 9. It looks kind of like it's in standard form. Ax plus by equals c. 3x minus 6y equals 9. And before I go any further, I should say, don't be freaked out that we have a minus, whereas the standard form has a plus, simply because we could write this as plus negative 6y, right? We could write it as plus negative 6y. That's the same as minus 6y. So even though the standard form shows a plus in there, we might have minuses sometimes. Now, this meets bullet point number 1. A, b, and c are integers, check. It meets bullet point number 2. A is positive. We have a positive number of x's, looking good so far. But the third bullet point is the one we haven't quite met yet, and that is that the greatest common factor of a, b, and c is 1. I can divide something out from all those numbers. Hopefully you've spotted what? 3 goes into each of these. And so that would leave me with x minus 6 divided by 3, so 2y equals 9 divided by 3, which is 3. And that is the standard form of this linear equation. A, b, and c are all integers, whole numbers. A is positive, we have positive x's, and there's nothing we can divide out anymore from all 3 numbers. So the other part of this question asks us to identify what a, b, and c equal. C, fairly obvious if we're comparing it to our standard form general equation. C is 3, just the number part on the other side of the equation. B is the number of y's, and it's important that we write -2. That negative is significant and is important, and it is incorrect if we don't include that negative and just said 2. So we do want to say -2 there. How many x's do we have? We don't see a number in front of the x's, but if you remember, that's our clue. It's the invisible 1. 1x is the same as just x. We often just write it as x. So x minus 2y equals 3 means a is 1, b is -2, and c is 3. So first thing we did on that problem, we put it into standard form, we rearranged, and then we divided, and then once we had it in standard form, identified a, b, and c. What I would like you to do, and what I will ask you to do, is follow the exact same process on this second problem. You're going to have to move things around. You're going to have to rearrange so that it looks like ax plus by equals c. Put it in standard form, make sure everything's an integer, make sure your a is positive, and that the greatest common factor of a, b, and c is 1, nothing to divide out. So I'm going to ask you to do that right now and then identify a, b, and c. I'm going to pause the recording, fill in my own work, and then be able to take a look at it here in just a second. So pause your video and we will get back to this shortly. All right, so hopefully you had a chance to work this second problem, and hopefully your work looks something like mine. On the left-hand side of the screen, I rearranged, I subtracted the x, then I got the 11 y's over to the right-hand side to keep my x's positive. I moved that -1 over to the left, and going from the bottom left of my screen And then you see the arrow kind of just showing you here's where my work led me because I ran out of room, what I just highlighted in yellow there. I did flip the two sides of the equation, and we can do this. An equation is equal. I mean, that's the definition. And so it's equal on the left and the right. So if, you'll notice down here in the bottom left, I had -1 equals 3x minus 11y. So in standard form terms, it was like c equals ax plus by. It's not wrong, but I like putting it just exactly like standard form shows. 3x minus 11y equals -1. And then my a, b, and c being 3, -11, -1. So if you did not get that for a result, again, pause the video, rewind, take a look at that first problem we did to make sure you follow, take a look at my work to see kind of where we diverged. But that is what we should get for the second one. And if you had questions with that, make sure you write them down. So next time we meet, you can ask those questions to me live and we can get that straightened out. So there's really only one other thing for us to talk about in this section at this point, and that is how do we graph a linear equation that is in standard form? So I'm going to put it kind of in the center of the screen. You see I have a 3-step method there. Step 1 is find the x-intercept and the y-intercept, which I'll be showing you how to do in just a second. Step 2, graph those points, and step 3, draw a line through those points. So step 1, how do we find the x and y intercepts? Well, you notice that 3x minus 6y equals 9, it's not even in standard form. I'm going to do that really quickly first. I'm going to divide everything by 3. I noticed greatest common factor is not 1, so I'm going to make this x minus 2y equals 3. Looks a little familiar, hopefully. How do I find my x and my y intercepts from here? Now, here's what I want you to realize. The x-intercept, what is it? By definition, it is where we hit the x-axis on the graph, where we intercept the x-axis on the graph. So let me draw an example on this graph. If I hit the x-axis right here, I don't know exactly where I'm hitting it on the x-axis, but you know something I do know? I know the y-coordinate of that point. The y-coordinate is 0. Because the y-coordinate when I hit the x-axis is 0. That's how I ended up on the x-axis. Similarly, if my x-intercept turned out to be over here, well, the y-coordinate is still 0 because for me to be on that axis, I can't have gone up, I can't have gone down. So to find the x-intercept, we are going to utilize that fact. To find the x-intercept, I know that y is 0. So I'm going to take my standard form of the equation, and I'm going to plug in 0 for y. I'm going to say x minus 2 times 0 has to equal 3. Because for my x-intercept, I know that y is 0. So 2 times 0 is 0. So x minus 0 equals 3. That means x equals 3. My x-intercept we just found. My x-intercept happens at 3, 0. X is 3, that's the x-coordinate, and y we already knew was 0. So I know that I am hitting the x-axis at 3, 0, and I just put that point right on my graph. What about the y-intercept? Well, you might see where this is going. Y-intercept is where I'm hitting the y-axis. Maybe it's right here. I don't know. But if it is there, I don't know exactly what y value that is, but I do know that the x value is 0 because the y-intercept is on the y-axis, which means I didn't go left and I didn't go right. X is 0 when I'm finding that y-intercept. So I'm going to do the exact same thing, except flip it around. I'm going to plug in 0 for x. Minus 2y equals 3. So 0. So we can get rid of that 0, just negative 2y equals 3, and y equals negative 3 divided by 2. Negative 3 divided by 2. So what does that mean? Well, that's negative 1.5. It's the fraction form of negative 1.5. So my y-intercept is 0 in the x direction, negative 3 halves in the y direction. So I'm going to box my x-intercept too. I like to box really important pieces of information, just in case when I'm coming back to them, I need to find them. So -3/2 down on the y-axis, 0, -3/2. So found the x and y intercepts, graphed those points. I'm going to grab my ruler, kind of put it right here. That looks about right. And draw my line. This is how we're going to graph an equation that is in standard form. Find the x-intercept by plugging in 0 for y. Find the y-intercept by plugging in 0 for x. And then plot those 2 points and connect them on the graph, drawing your line. If that made sense, awesome, let's move on. If not, pause it, rewind it, listen again to something I said. Again, if you have a question, jot it down so that when you're talking to me next, we can address that question. But if that all made sense, last problem of the day, I want you to pause this and I want you to put this equation in standard form, find the x-intercept by plugging in 0 for y, find the y-intercept by plugging in 0 for x, put those on a graph, draw the line, and then unpause the video to see if your graph looks like mine. Once again, I'm going to pause mine and I will be back when you are back. So go ahead, pause it, do your work, and then check in with my results here in just a second. All right, guys, hopefully you had a chance to work that problem. You'll notice my work just popped up on the screen. When I was working this problem, this had something that we haven't seen yet before, so I want to just make a quick note of it. First thing I did was I divided everything by 2. I know I need to get the greatest common factor to just be 1. So I ended up with -2x minus y equals 4. But then this second line here, since we haven't seen this before, I just want to make sure everyone sees what I did. I knew I needed my x's to be positive. And since they were -2x's at the moment, on this line I'm highlighting, I multiplied both sides of the equation by -1. We can do that. We can multiply on both sides of the equation by the same number. And so by multiplying by a -1, that's the trick to just flip the signs of everything in that equation. So -2x minus y equals 4 became +2x plus y equals -4. And that's how I got my standard form. After that, it was the same process, x-intercept, y-intercept, x-intercept plugging in 0 for y and solving, y-intercept plugging in 0 for x and solving, finding those 2 points, -2, 0 and 0, -4, and plotting them on the graph. So guys, standard form of linear equations, how to put something in standard form. What is standard form? How to graph something in standard form. I'm hoping this all made some sense. You're going to have some practice problems with this, so you'll get the chance to put it into action and make sure you really do understand it. But that's all for right now. If you had questions, please be sure to bring them up next time we meet. And otherwise, I will see you next video.